So in this case, we use what? Cross validation. Okay. What does the cross validation do? First of all, let me tell you what are the major types of cross validation, right? Thereafter, I will tell you what does the cross validation do, right? So generally, three major types of cross validation we consider. Means there are more. It is not like this. There are more cross validation processes are there, but generally, most of the cases you will find three. Okay. Out of three also, there is one which is mostly used. The name is k-fold cross validation. You might have heard about, but let me tell you other types of cross validation process as well, right? So it will be, just a minute. One of them is known as leave one out. Look, what is leave one out cross validation? Leave one out cross validation means it is a kind of a cross validation technique that was being used some times back. Nowadays, I guess very few people are using this thing, right? So it is not in so much use, or you can say not so much in trend. The reason behind it uses so much high computational power, means a good range of computational power required. Okay, you need a high computational power to work upon leave one out computer vision. Sorry, leave one out cross validation. Why it is that? Because in this case, what you have to do, suppose you, this is your data set, right? 1, 2, 3, okay, like this. So here the training will be done on whole data. You have to just leave any one of them. Okay, like one data you will leave for the train testing. This will be for testing, and the major part will be the training. Means just one sample for the testing. In the next cycle, next one sample for the testing. Okay, and rest all will be the training. In the third sample, again this one will be the testing, and rest all will be training. Means one by one, you just leave one sample. Means you will verify each and every sample. Okay, so you have to create, suppose you are having a 5,000 sample, so you can think of how much hectic process it is going to be. Or you are having a 1 lakh sample, then it is going to be 1 lakh loops. Okay, so a heavy computational power is going to be used. So in case of heavy computational power and so many things are there, that's why it is not in use as of now too much. Okay, but for the knowledge you can know it, but it is not going to be used because of its high processing powers requirement and all. Okay, next is known as your k-fold, right? What is basically k-fold? K-fold is same k-fold cross validation. Okay, what is k-fold is like? K-fold is like you just pick certain value like this, like you pick this certain value for training, so sorry, testing first. In the second case, you are just picking some other value. In the third case, you are just picking some other value. In the fourth case, you are picking some other value for testing. In the fifth case, you are picking some other value. So if this condition is there, that means it is a five-fold. The value of k is, what are samples basically? Samples are what? Samples are your data sets. In data sets, there are samples, right? Or like if you are having the last practical, in last practical, what we did, we are having total how many images? 2,742. Okay. So this is what your sample size total. Here I am defining, this is one, just a minute. What I defined over here actually, this is your complete sample, right? Here it is your complete sample. Complete sample means this is your complete data. It is not 5 different samples. It is your complete data, right? And on complete data, what you are doing, you are just picking, suppose 10, this complete data is having a size of, this is a complete data, and this is having a size of how much? Suppose this is having a size of total samples is 1000. Okay, this is your 1000 samples, means 1000 data. So out of 1000, what you are taking, you are just picking up 200 values. Sorry, 2000 values. Sorry, 200 values. 200 values for testing, and rest 800 values for training, right? This is the first step. In second step, again you are taking 200 value for testing, and 800 values for what? 800 values for training. Okay, in the third step, again you are taking 200 values for testing and 800 values for training. Fourth case, again you are doing the same, 200 values for testing and 800 values for training. But for each case, the data that is in testing and the data that is in training is different. Okay, the data in training and testings are not same. It is going to be different. Okay, so after doing 5 process, means 5-fold, k-fold, here I'm using 5-fold, means 5 times I'm using it. So after doing 5 process, suppose here the accuracy is 89%, right? Here the accuracy is 90%. Here the accuracy is 87%, and here the accuracy is 95%, and here the accuracy is 92%. Okay, if this is your case, okay. So in this case, when you have to present your model, how will you present your model? You will present your model either by calculating the mean accuracy, mean of all these value, because you trained your model for 5 different times and each time you are getting a different accuracy. So you can consider the mean. You can calculate the standard deviations. Okay, you can calculate the standard deviation of this accuracy, or you can just tell that my model is posing minimum accuracy, which is 87%, means, and maximum accuracy 95%. That's why I told this is not any kind of algorithm. Cross validation is not any algorithm. Cross validation is not a kind of a training thing. It is a status. It is just a statistic over a data set. Okay. So you have to just apply this approach to get out the things like what is the minimum accuracy of your model and what is the maximum accuracy of your model. Got it? Any doubt? Yeah. So one more thing is there. One more problem might possible. Okay, just discuss that problem. Suppose in this 200 sample, just suppose the thing that kind of data that we were having a iris data, right? In the iris data, I don't know you have noticed or not. What you did, there was 150 samples. Okay, there was 150 samples, and out of 150 samples, first 50 samples was of setosa, and then 50 samples was of versicolor, and then we have a virginica. Total 150 samples were there. Okay. Now the challenge over here is if you divide train test split, if you do the train test split over here, okay, if you do the train test split over here, then the case is like you will use certain fold. Suppose you decided k fold, suppose you decided 5-fold. So out of 150 you decided 30 data you will put in testing. Okay, 30 data you will put in testing and 120 data will be used for training. And you are using what? K-fold. Okay, K-fold cross validation. That means validating the things. It is just a validation approach. So it will take, suppose, 30 from here. So if it is taking 30 from here, that means in testing data we are having just single type of element, and the element is what? It is of virginica. In testing data we don't have any versicolor element, we don't have any kind of a setosa element. Okay. So in the next step, this k-fold, this particular testing thing will shift upward. Okay, means in the next case it will, this 30 it will take. Okay, so as it will take the next 30, that means again 20 value of virginica and just 10 value of versicolor. For the next 30, again only versicolor will be there. Okay. Again next 30, just 10 value of versicolor and just 20 value of setosa. Okay, so there is a challenge over here. Means the challenge, the main challenge is like for each particular testing or for each particular validation, your accuracy is going to be changed a lot, and the validation is going to be done on a uniform set of data. Means there are a data set in which there is a uniform value present. Like if it is 1, then all are 1. If it is 0, then all are 0. If it is 2, then all are 2. So this is a limitation of K-fold. So how it can be sorted out? It can be sorted out by either picking up the things random that we already did. Okay, but picking up the things random, what we were picking up just for one time random. Okay, otherwise there is one more type of cross validation technique, and that cross validation technique is named as what? stratified k-fold. Okay, a stratified k-fold. What is a stratified k-fold basically? A stratified k-fold means, let me clear these things first so that I can explain. Just give me a minute to clear this drawings. What is a stratified k-fold means? A stratified k-fold means, again, you are having 1,000 samples like this, 1,000 samples and 1,000 samples. Suppose 3 times you are trying for cross validation. You have to validate 3 times on different training and testing set, right? So what you pick? You pick some testing data. So you'll pick the testing data how? From anywhere. Okay, like this. This is your testing data. In the second case, this is going to be a testing data. In the third case, this is going to be a testing data, right? So with a stratified k-fold, what will happen? It will be like the data, you can say, will be divided in a uniform format. That means if in this data you are having 0, 1 and 2, okay, 0, 1 and 2 as label, okay, so complete data is suppose 1000. So in testing set you will have 33%, 33.33% of 0. Now I hope you understand. 33.3% of 1, okay, and 33.3% of 2. So this is a thing that you can do. Okay, that means you can divide the data into 3 categories, that is 0, 1 and 2. Means your data has been divided into 3 categories, 0, 1 and 2. So as you divide the data into training and testing set, then testing set will contain the equal proportion of each category. Got it? Testing set will contain the equal proportion of each category. So this is called a stratified k-fold. Okay. So depending upon your need, whatever the data you are having, according to your need, according to your conditions, you can use any type of cross validation technique. I hope you got it. Okay. Is it clear? Any doubt? Okay. So basically, what you need to do now, let me give a small example. Later on, you can use this thing for your different purpose. What you can do for this thing, define an array, import numpy as np, data is equal to np dot array, right? Any sort of data you can define, like 2.3 comma 5.6 comma 8.3 comma 7.8 comma 9.0 comma 4.3 comma 2.1 comma 5.7 comma 9.6. Okay. Suppose this is data that I have defined. Okay. Now what will happen with k-fold? For using the k-fold, you can just import it from sklearn dot model selection. So last time when we use model selection, we use model selection in trend test split, right? So this is for trend test split only, but here the splitting will be done through k-fold. Okay. Import k-fold, right? Thereafter, just define it, k-fold equal to k-fold. How many fold you need? You need 3 fold, right? Just 3. Just wait. I was searching for something. Okay, anyway, we can just define it. After defining, what you can do, okay, so it is done. So thereafter, it will just use k fold dot split. But to split, you have to split the data, right? Split data. So you're getting nothing because it is already stored. So if you want to see the things, what you have to do, you have to do train, right? Train comma test, right? Too many values to unpack. Okay. What is showing too many values to unpack? Expected two. Oh, just single value is there. It's enough single value. Then why it is showing? Because I have to split just one value, right? No. Okay. Just let me check. I guess I will just check the documentation also. First, let me check on my own. Then I will check the documentation. It is not working. I guess it should work. Yeah. Okay, I have to pass data train and data test, right? This thing I was missing, data train and data test, right? So basically now you can see how the value is splitted. You can see for the all three times you are having different training and testing. This thing you can apply over a huge data also. Okay, if you are having a bigger data size, there also you can apply, and then you can generate a training and testing and can check your accuracy, or you can say you can cross validate your model on different sets of training and testing data. Okay, you can just cross validate on different sets of training and testing data. Apart from this, I want that you should go to the documentation of this one, scikit-learn, and check how to use a stratified K4. Okay, this also you can get if you just import and just feed. That's it. Okay. Done. So this is one of the approach through which you learn the things. One more thing, that is correlation matrix. Have I told this about? Have I told you about correlation matrix? Yeah, right. It is if data is on. It is useful. It is useful only to give you kind of a range. Like my model is basically showing accuracy between 90% to 96%, like that. Okay, so if data is quite large, then generally it is not that much of useful. And it depends upon the usage also. Yeah. Have I told you about correlation matrix? Anyone? I guess I had not told, right? I didn't told about it. No. Okay. What is correlation matrix basically? Correlation matrix basically generates the correlation between different features element. The feature reduction, I guess I told you, it is like correlation matrix can be used to generate this thing. I guess I missed. I should tell you. It generates the relationship between different features. Okay, relationship between different features means what? Let's use a data set first. Let me take a data. This is one of the important things, right? So let me just take a data set. Thereafter I will tell you which data should we use. Any simple data we can use so that we can understand it. Okay, let me take this data. Advertising data. Let me take a data that is advertising data, right? Data that we had already used earlier. ADV is equal to PD dot read CSV, right? These are basically statistics, right? So okay, so this is a data I'm having, right? Now we'll understand what is correlation matrix basically. So what I will do, ADV, I will just use, just a minute. I can use index call is equal to 0. So what I am getting over here, look, I am getting a matrix, right? This is one of the important tool that you can use to find the correlation between different elements or different features, right? So this will also help you in ignoring some of the feature. Okay, the feature that is not important, those features you can also ignore, right? So it is saying what? Here I am getting a matrix. So this matrix is a 4 cross 4. Why? Because number of feature is 4. Okay. So what this is telling you? Let me draw a matrix for it. Okay. This is a matrix. So it is telling you like this. Correlation of TV with respect to TV. Got it? Correlation of TV with respect to radio. Okay, means how TV feature is related to radio. Means how the if it is showing that TV feature 0.05, that means TV feature is very less related to radio. Okay, that means as the TV, value of TV is increasing, then it is not so much affecting the radio value. Okay. How TV feature is related to newspaper, right? Wait, let me complete it. How TV feature is related to sales value. You can see T feature is highly related to sales value. That's why it is showing 0.78. Okay. Thereafter, it is radio feature. How radio is related to TV. So you can see these two value will be same. Okay. These two value you can see same because the relation between TV and radio versus TV will always remain same, right? That's why these two value will remain same, right? Yeah. No, it is not same as covariance. Okay, it is not same as covariance matrix. Covariance matrix is something different. Covariance matrix is like if you are using two feature, okay, and using two feature, if you are plotting a line, right? If you are plotting a line, if you are plotting a, you can say best fit line over a two feature, then the error, you can say the error value between the real point and that particular line is actually covariance. I mean, variance means what? Variance means error. Okay, variance means error. Okay, and here it is the correlation means what? If the value of TV is increasing, then how it is affecting the radio value? Is the radio value is also increasing the same way? If it will be negative, that means something is inversely proportional. If it is positive, that means it is directly proportional. Okay, here it is showing the, you can see correlation of TV and sales is 0.78. That is a huge value. That's why the sales part is highly dependent upon the TV, right? Let me complete this thing so you can understand this thing better. Thereafter, we have a radio versus radio. Then we have a radio versus newspaper. Then we have a radio versus sales. Got it? So same thing is there again. You can continue. Now you might have understand. This is C of newspaper versus TV. Then we have a C of newspaper versus radio. Then we have a C of newspaper versus newspaper. Then we have a C of newspaper versus sales. This is correlation and that is covariance. So please do take care difference between correlation and covariance. If not, then wait a minute, I will explain the difference also. It is what? This is sales versus TV. This is sales versus radio. This is sales versus newspaper. This is sales versus sales. So you can see diagonally all is one. Why diagonally all is one? Because you know all will be affected by themselves, that will always remain one. Right? So we will see now sales value. Okay, sales value is what? Sales value is depending upon what? Mostly it is depending upon what? You can see it is 0.7 means highly dependent upon TV. Okay, radio versus sales means on radio it is almost 0.57 means you can say little bit moderate dependent upon the radio value. Okay, whatever the radio expense that one is making. Okay, so it is moderately affecting the sales, but it is very less affected by the newspaper change. That's why 0.22. You can see the value is 0.22. That means the sales are very less affected by the newspaper change, or you can say newspaper value. Okay, so that's why changing you had seen in the real data also, as we added the newspaper part, the sales value, or you can say the error value, were not changed too much. The error value will remain same. Okay, that will not change too much. It is because the sales are not too much dependent upon the newspaper. It is highly dependent upon the TV and moderately dependent upon the radio. Okay. The same way other parts are there. So this is called correlation matrix, through which you can just calculate the correlation between each particular thing that has been given to you. And covariance is what? Covariance is the variance. Variance means what? Difference, or you can say error. Okay, error means what? If you are plotting a line, if you are using just these two, covariance something is called unsupervised learning approach. Okay, it is not unsupervised learning approach, right? It is a statistics, and covariance is a unsupervised learning approach. So if instead of these two things you want to use just any one feature, okay, instead of using TV and radio, if you want to use a single feature, any one feature, okay, so if you will use that feature, then what will be the error value? What will be the existing error value? What will be the existing difference value from the original feature? That is called covariance. Getting my point? Is the doubts clear? Is the difference clear, or still someone is having a doubt? So Shreyans, is it clear? Parthiv, is it clear? Yeah. So if anyone at any time, like in interview or something, someone asks you like what is covariance, or what is the difference between correlation and covariance? Correlation will develop the relationship status. Sorry, it will give you the relationship value. Okay, relationship value between two different features, and covariance will give you the variance value. If in place of those two features, I want to use any single feature, then what possible error, what possible differences that I will encounter if in place of those two features I am using any single feature. That is called covariance. Okay. So, and one more important part, covariance thing is something that is called unsupervised learning approach. It is being classified as unsupervised, considered as unsupervised learning approach, and this one is completely considered as statistics, right? So I hope it's done. Yesterday I had given an assignment to you. Is anyone tried? Had anyone tried? Yeah. So what possible? What is the best accuracy that you achieved? 68% through ANN. Means trying everything, right? Okay. So why did you think why was it so? Why could not you get the best possible error? Why it is like we're getting only that much accuracy? 68, 67%. Okay, we'll see now. We'll see. We'll try to develop the accuracy more. Before doing it, let me share some projects with you. Projects name, because those for all those who had enrolled for more number of weeks, right? They needs to complete certain projects, right? So those projects you might think of, or I am sharing some kind of, and after sharing it, I will solve that particular problem. Why accuracy is less and what can be applied over that? Because that is one of the, as you solve this particular project, the cats versus dog, a lot many projects, a lot many good level of projects you can solve, right? So that's why we'll work upon it. So I hope you can see the notepad, right? No? Okay. So I can now I can see. So there are certain projects on which you can work upon if you really want to work, like credit card fraud detection. You can use some unsupervised learning process for credit card fraud, like just like we had used for customer churn classification, right? Customer churn classification on mall data. Okay, we had used mall data, right? Okay, predict using a model if loan can be granted, right? Animal image classification. Okay. Customer thereafter customer churn means based upon the customer behavior, like how much expense they are making, and how much kind of earning they are how much earning they are having and how much expense they are making, so that thing. So customer churn classification, case detection, housing and real estate price prediction, thereafter cancer tumor classification. Okay, diabetic patient classification, fake news detection, emoji detector. Emoji detector means what? If one is making a face, okay, if one is making certain face, so based upon his facial expression, a emoji can be generated like that. Facial expression generator, sorry, facial expression detection. Like someone is smiling, someone is crying, someone is what, anyone is doing like that. Hand written digit recognition, COVID data analysis, predicting future trend. So 14th, there are some uh, cats versus dogs, predictive modeling. So this many things you can create, right? You can select if you are having some idea within your, like if you want to, like you can use some protein based classification or something like that. The food protein and other ingredients, other kind of nutritive nutritive ingredients prediction. Like from a food items, you can just predict some what are the protein, how many, what are the other ingredients. So there are certain project ideas, right? So you can just work upon in this kind of projects. You can just either click the image or you can just note it down. Apart from this, if you want to work upon certain other projects as well, okay, that also you can work upon. Okay, it's almost your wish, whatever you want to use. Okay, but if you have to complete the project in coming 3 to 4 weeks for your project completion later, okay, because this will be your training later, or you can say training certificates. Apart from training certificate, you have to also complete the projects for all those who had enrolled for more than 2 weeks. Okay, so once they will complete the project, then only they will get the project completion certificates and all. Okay, whatever the project they will do, and please try to do the project as good as possible, because again gradings will be there, right? It is not like that anything you are writing. So project report you need to submit. Okay, and that report will be analyzed with your code and all, and thereafter some grades will be given, and based upon that gradings, your certificates will be released, right? Okay, so let's see. Shall I close it? I guess you have clicked it, right? Okay, so next thing, come to this part. What we did, what I had given to you was like about cats and dogs. So I guess half of the part there is no doubt you had completed, but the problem why accuracy was low. Accuracy was low because 67% is really very low accuracy. You can't rely upon that. The accuracy was low. The reason behind orientations. First of all, the image is quite complex and it is having orientations. So if the data is that much complex, right? So you can't rely upon the conventional technique, the older, or you can say the things that are used sometimes back. Like now, latest things you have to use. So in the latest part, it will be like ANN you can use. But again, if you're going to use ANN, we are getting a low accuracy. So that means something more improvisation required. So that improvisation is basically what? That improvisation is known as more complex neural network model. Okay. So apart from ANN, one neural network model that we discuss is what is known as, shall I save it or not? Anyway, just a minute. Okay. That is called CNN, right? So let's understand the CNN. Aman, you have to complete the projects on your own, right? Whatever we have learned based upon that, okay? And you will get the data. You have to search the data set, and after completing the project, okay, if you need any kind of help, any kind of problems you face, then you can directly write to us, okay? Even you can directly mail me. I am putting down my mail ID. You can mail me, or you can mail to the company uh, official mail ID also, right? So as you mail over here, if you face any problem, any doubts, we'll try to solve the things, okay? And these projects you have to submit in a soft copy only, no hard copy is required. You have to just complete the code. You have to just complete it. You have to write down your approach, like what is the data set, what are the algorithms that you have used, why you have used that algorithm, what are different kind of statistics you have used, what are the how you filter the data, what is data science, okay, how you filtered, how you modeled, okay, how you analyze the data, okay, how you create a meaningful data, and how you applied the algorithm, and why you have applied only this algorithms, okay, and different other things. So basically all the process basically you have to mention, okay, and thereafter codes also mentioned, and thereafter the outputs also mentioned, accuracy also mentioned, error rate also mentioned, and after completing the things you can submit the project in a form of project report, okay. So you have to submit it, and then we can again after 25 or 30 days we can just schedule a session for the project discussion. Whatever the project to complete, whatever the problems that you face during the during doing the project, there might be a lot of problem you might face, right? So at that time we can have a session to discuss the some problems or something that you didn't understood, like that. So next approach is known as what? Okay, is known as some better kind of a neural network, and this better neural network is known as what? CNN, or convolutional neural network. Okay, so please do understand this thing. This is the more one of the things that I'm explaining that was not actually there, but I want that you should know, because with the CNN a lot of good models you can create, right? So what you are having a set data like this, right? So in NN what you do, you directly use the data that you are using cats and dogs. If you use normal algorithm, then you will get accuracy of around 20% or 25%. But you are using ANN, so you're getting something 65 to 67%, right? But still, that is not a good thing. Okay, so we can get much better accuracy. So how can we get? We can get by using CNN. So what is CNN? In ANN, whatever the values are there, whatever the input values are there, you use those value as a input neurons, right? And in CNN, it is not like that. Okay, there is a little bit difference. Okay, what is the difference? Let us discuss. Suppose this is your data set, right? So this data set will be applied, or you can say there will be a kernel, or there will be a filter. Whatever you want to name, you can give it name. There are some people who call this thing as a filter. There are some people who call this thing as a kernel, right? So if this is a kernel, so this kernel will be applied over your data. This kernel will have certain values, okay, like this. It can be -1. You can say it is a starting values, -1, -1. It is just a starting value, and that basically changes to reduce the errors value. Okay, first it will start like this, and thereafter gradually using the gradient descent it changes, right? Done. Okay, so it is done. So this will be applied over here. So applying means what? Applying means it will be applied over the data that you are having. It is like this. Sorry, just a minute. It will be like this. It will be applied over here. As it applied over here, it will just extract this many information, means 3 cross 3 into outside. Okay, it will just extract this information outside. Okay. Thereafter, there will be a certain shift. Okay, there will be a certain shift. Okay, now just you can see what how much shift it is. Now there will be a certain shift like this. It means two features, or you can say two column of older window and one column from a new data. Okay, this will happen. So it will create one more window. Then again there will be a little shift. So you can see each particular feature will be considered for multiple number of times. Then again there will be a small shift, and this will be considered. So what is this? This is called convolutional windows, right? And this will continue vertically also, like this. Again, and again. Okay. So there is a matrix of, you can say, 1, 2, 3, 4, 5, 6. Right? 6 cross 6, from 6 cross 6 matrix, what happened? You have generated 8 matrix, each of 3 cross 3. Okay, sorry, you have generated how many matrix? 16 matrix. Okay, you have generated 16 matrix, each of 3 cross 3. Okay, so what you did, you are considering the each value for the multiple number of times. So this is called convolutional matrices, or you can say convolutional layers. Okay, how much shift you have to do, it will be decided by you. Okay, no one will decide it. It will be totally depends upon you that how much shift basically you are doing. Okay, after each layer you are shifting for single times or shifting for 2 times. And what this shifting is known as? This shifting is known as, basically, let me tell you, this shifting is known as strides. Okay, this is known as strides. Okay, so whatever the strides value will be there, based upon that strides value, your convolutional matrix will be created. And this is known as what? Filter. This will be filter, and that will be strides, and based upon strides and filter, your value will be calculated. Okay. Thereafter, this is a convolutional layer, right? Okay, this is a convolutional layer. Okay, so after convolutional layer, what will happen? There will be next thing, that will go. What will be the next part? The next part will be, this is called, from here you went here, and after here you will come back over here. So the next part will be known as max pooling. Okay, so what is max pooling? What I am discussing CNN, convolutional neural network. Okay, max pooling will be what? From each particular layer, the maximum value will be pulled out. Okay, that means you are having how many layers? You are having 8 into 8, sorry, 4 into 4, 16 layers. Okay, so from each particular layer, what you have to pull out? You have to pull out the maximum value. So what basically it will look like this. This is 3 cross 3, right? This is 3 cross 3. So from 3 cross 3, the maximum value you will pull out. Okay, as you pull out the maximum value, then there will be a new matrix created. All of us know. From each value you are pulling out the maximum value, so a new matrix will be created. Okay, and this matrix will have how much value? This matrix will have 4 cross 4. So you can see 6 cross 6 matrix will be converted into 4 cross 4. So what is the benefit of using it? The benefit is like each particular smaller and a smaller pixel value, a smaller features, whatever the smallest to a smallest feature will be considered for multiple number of times. So loss in data will be very less. That's why each important feature, each smallest feature can be calculated, can be used for multiple times, and can be considered. Okay. So again, you got it 4 cross 4. So after you got 4 cross 4, what will happen? If it is required, okay, to create more convolutional layer, you can create it. Like for example, again you are using a stride 1 and filter 3 cross 3. Again you are using a stride 1 and filter 3 cross 3. So what will happen? It will let you form again 3 cross 3. This will be stride 1 and 3 cross 3. So with new stride 1 and 3 cross 3, what are you getting? You are getting again a layer, a convolutional layer with 4 matrix, and each matrix is having what? 3 cross 3 value. Again max pooling will be done. So after max pooling, after you put a max pooling over here, what will you get? You will get something called 2 cross 2 matrix, right? You'll get what? 2 cross 2 matrix. So after you satisfied, okay, 2, 3, 4 layers you have created. And after 2 or 3 or 4 layers, you said, okay, it's done. Thereafter, something that is created is known as what is known as best is known as FCN, fully connected layer. Okay, what is fully connected layer? Fully connected layer means what? These four value will act as your input layer now, which will be connected to output layer like this, right? Which will be connected to output layer like this, and then the same concept that we have studied will be applied. It will be connected like this, 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 this. Got it? So this is how your complete things work. Okay, this is how your complete things work in CNN. So a smallest to smallest feature will be considered and will be used for in the model development. That's why if your you can say the features gets more complex, you can move ahead to this particular thing. Okay, obviously it will use so much computational power, so always it is not recommended. But in case if your feature gets too complicated, you can move to this particular convolutional neural network. So what are the important terms in it? The important terms are like, let me write over here. First, input layer. All of us know input layer. Second, strides. Third, filter. Fourth, convo convolution layer. Convolution layer, convolution matrix. Fifth, it is max pooling. Sixth, it is FCN, that is fully connected layer. And seventh, it is output layer. So these many things are important terms in CNN. So anyone is having any questions regarding it, or you want to deploy it? You can just think of, okay, and if you are having any questions, you can ask. Okay, okay, Shreyans, I will explain once more. Look here, you are having a data set, right? In that data set, you use all the values as your input neurons. Okay, as you use all the values as your input neurons, then what will happen? It will be connected to hidden layer, then output layer. Right? So there might be a chance, you know, if certain value will gets negative, right? Certain hidden neuron value will gets negative, that will be converted into 0. So there might be a chance that some features, some important features gets neglected or is not considered. Right? So, or in the case of your image, in the image that we use is a complex set of image. In that set of image, the orientation is not same. Okay, like some dog is sleeping, some cat is like in other portion, like there, every particular animal is having different kinds of it is positions, right? So in that kind of image, there are very small things that are basically considered. For example, if you see the image, the general dogs, the ears of dogs are quite, it will be like in a downward direction, and ears of cats are in a kind of upward direction, right? So there is a change, right? So the very small change you have to take care. Okay, means your model should take care of that much small changes as well. Okay. So how is it possible? Is it possible? It is possible if you consider each particular value. You can say each particular feature, okay, repeatedly. Okay, so you can see if you want in this particular data, if you see over here, this particular feature, it's considered in first layer, And as this thing is considered again, means this block is considered again in the second layer. What is the second layer block? The second layer, the block is, this value is picked up, this much value is picked up according to filter. Okay, so as it is picked up, that means this block is again considered, okay, in the second block, means it is there in first block as well as it is there in second block. Okay, if you consider this one, okay, this block is considered in first block, this is also considered in second block, and this will also be considered in third block. Right? So this is how each feature will be considered for the multiple number of times. So in case, suppose while doing the max pooling, okay, max pooling means what? Maximum value of the pixel, okay, means a feature which is maximum effective. So if suppose while we do the max pooling from the first layer, okay, if we are doing the max pooling from the first layer, right, from here to here, okay, so in that case the max pooling value will come over here. So in that case, suppose the next most important feature will not be considered, suppose, because max out of 9 only one will be the maximum. So suppose second most important feature is not going to be considered because of any reason, because it is having some lower value. So that feature will be considered from this particular layer if that is that much important. Okay, that is the maximum, so that much important, that will be considered over here because the same feature is there in the second layer also. The same way, if you, the third column, if you consider third column, then third column feature is there in first layer, second layer as well as in third layer. That means if suppose any feature is so much important, so that will be considered for 3 times or 4 times or 5 times. Okay, so that means if some feature is getting considered for 4 or 5 times, that means that is so much important, so that can be used as an important feature for prediction. Right? So this is the main funda of CNN. Just repeat the value and repeat the things. Okay, so it will be like from the first layer, it will a kind of a filter will be applied. Filter will have certain value like -1, 0 and 1. Why this value is required? This value is required so that it can change the, this minus 1 will be multiplied by the first value, right? This will be multiplied by the first value. While picking up, this will be multiplied with this will be multiplied with this. And once it will multiply, there will be certain output calculated. That output will be there in the next layer. Okay. So why are we using it? We are using it because this will help us a lot in error optimizing. Okay. In reverse direction or in reverse propagation or in backward propagation, what happens? This value will manipulate itself. Okay, -1, 0 and 1. This value will change just like the gradient descent formula that we use. This will act as a coefficient or as a parameter. Okay, what is coefficient or parameter? Coefficient or parameter, all of us know, the important factor that used to predict something, right? So this value will change in such a way that error can be minimized. Okay, so this will again what certain more coefficients that will be used to minimize the things, minimize the error. So it will minimize the error. It will just apply over the first layer, give you next convolutional layer. From the convolutional layer, you are picking up the maximum value. You are creating one more matrix. Over that matrix, again applying the convolutional layers thing, convolutional layer concept, again creating convolutional matrix, again doing the max pooling. It's repeatedly 1, 2, 3, 4, 5, 6, 7 times you can do. Okay, and after you think, okay, it's okay, now we should proceed, you can create a max pooling, you can create a fully connected layer out of it. And from fully connected layer, output will be connected, and then output will predict whatever the things will be predicted. That will depends upon the neurons probability, right? Means what is it? This is your, what is it? This is your simple neural network that you had created yesterday. This is simple neural network that you had created yesterday. But before creating this neural network, these many processes will be applied. Whatever the process that we had discussed, okay, in CNN. Means before coming to the point that we had discussed yesterday, these many processes will be applied just to make sure that most important features should be considered. It should not be neglected. So I'm getting some clarity. Yeah. So actually, how we deploy it, with the deployment, you will get more clarity, right? So for deployment, we need a data, right? I guess data is already there with you. So let's start. You can just be ready with a feature extracted, right? I will just tell you. Hmm, okay. I will just do the coding quite fast because all of you know about it. Import CV2 is what? CV2, NumPy, OS, random dot shuffle is what? Random dot shuffle will just shuffle the data, right? Shuffle the data means what? As I told you, first there is all dogs image, the images, then cats images. So it will just shuffle the data, you can say. Okay. Thereafter, we find the things like this. So two directories are there, train and test. On train, we are having the data present with her images having the names. Okay. In test, we are having just images, no names present. So predictions can be made over test. Image size I'm defining as 50. You can define something else also, like later on we'll define it. Leave it. Okay. A learning rate is 0.003. Okay. This thing also you might not using, right? You are not using any learning rate, right? You can use some learning rate as well, because the importance of learning rate I explained. Okay. Thereafter, I need labels, right? So just use this thing for the labels, right? All of us know what it will do. Okay. So this is your feature and label extraction. All of you did it. Okay. So I don't want that you should again try to do it. Okay. So just I will use create. I'll just call it. This one is little bit complex. I told you quite easier way to extract feature and labels. So please follow that thing only. Don't try to come over here. Right. It's a little bit complex. I will share this code with you. Don't worry, but this is a little bit complex, right? So why to use complex things? So 60 cross 60 I am using. Okay. So what is it? This is a TQDM. The library that I have imported is TQDM. Okay. Through TQDM, a graph is basically created, a kind of a progress bar, right? So only TQDM needs to put over it. That's it. You can also use this. Okay. From TQDM, import TQDM in port. Just use over your TQDM. It's your need. If you want, if you don't want, then you can leave it. Okay. So from TQDM, you can just import TQDM. Okay. After this, you have to create a convolutional neural network, right? So how to create convolutional neural network? Okay. So there's one way through which you can create is Keras, right? So let's open the Keras documentation. Okay. There it is. If you scroll down somewhere, you'll get the CNN kind of thing. Why it is recurrent layer, embedding, convolutional layers, right? So what I want, you should go through it, okay, and then you should try to create a convolutional neural network using Keras. Okay. What I will tell you creating a convolutional neural network using some other library that is called TF-Learn. Okay, so that you can have a knowledge, because I had already told you Keras, you have to just put your own kind of a brain to work upon it. So I will tell you use of one more library that is called TF-Learn. Okay, so TF-Learn is also important library in case of neural networks and deep learning. So you should know about this one also. So these are two leading libraries you can say at this stage. One is TF-Learn, second is Keras. TensorFlow deep learning library, right? This is also important that you can learn. So how to create it? All of us know there are certain library that we have to use. Okay, TQT means, yeah, that's it, that's it. No other significance, just to see progress. No other significance. Okay, so it's like, okay, what I was telling, TF-Learn will be used for what? Creating the CNN network. Okay, so how to use TF-Learn? You have to first call the libraries. I will go very fast because it's like the things that we have already explained. So you have to import TF-Learn, and from TF-Learn there are certain things you have to import. First thing, this type of layers. What are types of layer? We have a convolutional 2D layers and max pool 2D. Okay. So in our layering, two things are used, two types of layer are used. As I told you when I was explaining, the first layer was convolutional layer and second layer was max pooled layer. Okay. So first we create the convolutional layer, and from that convolutional layer we just max pull the thing. So this library will do that thing. Okay. This is mentioned in this document if you want to read, right? And the same sort of process is used in Keras. Okay. Only little bit changes might be there, like instead of using conv underscore 2D, it will be conv 2D. Okay, so whatever the changes are there, that you have to, once you know how to use this library, please put your effort to understand how to use Keras library. If not, then you can just ask me. Thereafter, you will define the input data to take the input, dropout, and fully connected. Fully connected I explained, input I explained, regression that is used to optimize the things. Dropout. What is dropout? Dropout is used in your model just to make the learnings quite fast. Okay, that means what dropout will do? Dropout will be used at the last layer. Okay, so let me explain the dropout thing. It is like, suppose you are having this thing, input layer, right? 1, 2, 3, 4, 5, 6. This is your output layer. Okay. So all of us know input layer will be connected to output layer using certain weights value. Okay. So it is not just a single line, it is a weight value, right? Right. Right. So how many total weights are there? In this case, 1, 2, 3, 4, 5, 6. 6 into 3, that is 6 into 3, that is 18 weights might be there. 1, 2, 3, 4, 5, 6. 6 into 3, 18 weights are there, right? 18 weights. So how dropouts will work? You have to define in your model that how much dropout you want to use. So if you're using 50% of dropout, okay, 50% of dropout meaning is what? The 50% values or 50% weight value will not be considered for your kind of a that particular cycle. That means it will be like this. Total 18 weights are there. So out of 18, randomly any 50% weights value will not be considered for that cycle. Means what? Weight is equal to weight minus what? dE upon dW. Okay. So if it is weight 1, this formula will be used, right? So it will be used for any 9. Okay. Any 9. Okay. Remaining 9, it will not be considered. Those weights value will be just dropped out, will not be considered, will be considered 0. So if that is 0, that means whatever the values of output will be there, based upon that output will be monitored. In the next cycle, again randomly any other weights value will go to 0 and remaining weights value will be changed, will change. Okay. So it is just a random selection by your algorithm, by your framework. Okay. Each time 50%, if you have defined weight value 50%, it is not mandatory to define. You can also not define weight with dropout. If you don't define dropout, then all the weights will be considered each time. Okay. But you define weight dropout, then it will find out the most significant weight by dropping the weights again and again. Means each time it is dropping 50% weights value, 50%, 50%. So it will find out, your algorithm will find out which weights values are important for your model. Okay, it will find out, because if you are having 18 weights, it is not like that all the 18 weights are important. Okay, so it will find out most significant 9 weights that are very much important for your model predictions. So for that thing, the library uses dropout. Okay, just to drop the values of weights in each cycle, not completely in a particular cycle of learning, right? So it is defined. After this, we have to define the layers, right? First of all, define the input layer. CONV by using a function input data. Shape will be what? Shape will be none. Why I had given none? Because the image data sample we don't know. Image size cross 1. Why 1? Because I am using a grayscale image over here. I have converted the image into grayscale. I am not using a colored image. You can see cb2.im read grayscale. Okay. So because I am using this thing, that means my image is getting rated grayscale. I am not using a color image. You can use color image also, but first I am using a grayscale. So that's why image size cross image size 1, and this none is what? For number of samples. I don't know how many number of samples are going to come, and I want to make this position open. That's why it is none. So image size will be what? All of us have defined as 60. All of us know that we have defined image size as 60. It will be 60 cross 61. Okay. And name is what? Name you have to define as an input, or anything you can define, any string you can define for assigning the input value in future. So it is what? This is your input layer for CNN. Input layer for CNN. So you have to work from this point actually, because before this point you already had worked, right? Okay. Next thing, after input layer, what we need? We need convolutional layers, right? So where can we get the convolutional layers? Just define the code for that. You can say first convolution con and max full layer. Now, from where this 56 value comes up, we have to discuss that thing. That is very important. Okay. And why are we defining only 56? Okay, this is your first convolutional layer. The same way, define multiples. Yes, Riyan, tell me. You know about it? Suppose 3 convolutional layer or 4 convolutional layer I am defining, right? So first I defined previously, it will be second. I'll explain it, just wait. It will be third, it will be fourth. It is total 4 layer I am defining. Okay. Con 2D. Con 2D, as I told you, is a library used for defining the convolutional layer. Con, con why? Because the previous layer it will take as an input. 56, that we'll discuss. It will be 52, it will be 48, and it will be 46. Got it? Okay. Let me write a formula. N minus f, n minus f upon s plus 1. What is this formula? This formula will tell you how much value you have to use over here, and the next part. Okay. How this formula will tell you? This formula will tell you n means what? N means previous layer you are using 60 cross 60, right? So it is 60. F means what? F means what is the filter size? You are using a filter size of 5 cross 5. So 5 upon S is what? Stride. What stride I am using? 1, because I am just making a shift of 1 plus 1. So you can get output 60 minus 5 is 55, 55 plus 1, 54. Sorry, 56. 65 minus 5, 55, 55 plus 1, 56. So this is your formula. You can verify this formula. We had used earlier what? 6 cross 6. Okay, what we used earlier, we had used something called 6 cross 6, right? If you remember, we had used a data that was 6 cross 6, right? Okay. And we had applied a filter over that in the example that was 3. This was a filter that we applied, 3 cross 3, or kernel that we applied, that is 3 cross 3. So calculation says 6, that is minus n minus f, that is n minus f means 6 minus 3 upon a stride. What was the stride value? 1 plus 1. So it is 3 plus 1. And if you remember, we were getting what? We were getting 4 cross 4. Was it or not? We were getting, at last, we were getting in the next layer, we were getting a matrix of 4 cross 4. Means from 6 cross 6, we have generated 4 cross 4. Again on 4 cross 4, I have applied 3 cross 3 filter. So on 4, if I apply a filter of 3 cross 3, so n minus f, stride was 1 plus 1. You might have remember the last value that we got was what? 2. And 2 you can get by 4 minus 3, 1 plus 1, 2. Got it? Formula is clear for all of you? Yeah? N minus f plus 1. Is it clear for all of you? N minus f upon s plus 1. Because whenever you are going to create any kind of convolutional layer, please give a proper value. It is not like that something anything could be other like writing over there. It is not possible. You have to write, you have to calculate, and then you have to write for any kind of library. Is it clear or having any doubt? You can ask. Chance, anyone? Okay. Okay. One more time. Okay. Again, I will explain it. Just a minute. Yeah. Right. Right. Look here. Here we are having what? We are having a matrix of size 60 cross 60, right? So that is the input layer. So what will be the next layer? What will be the size of next layer? How can we decide? We can decide by using a formula. The formula is n, that is number of, that is the shape of your data, and n is what over here? 60. Here n is 60, right? Minus f, minus f is what? Filter size. So here filter size is what? 5, because we are using filter size is 5. Here we have defined over. This is for filter value. Okay. Activation you all of you know. So n minus f upon s. S is what? Stride. Stride means what? As I told you, how much shift is there from the previous window to the next window. From the previous window to the next window. We are using a stride as 1, right? And plus 1. So 60 minus 5 will be what? 60 minus 5 will be 55. And then plus 1. So it will be what? 56. Got it? So what you are getting from 60, whatever the value that you are having, the next layer should contain 56 cross 56 input. That's why we have defined 56 earlier. That means we have created a placeholder of 56 cross 50. Placeholder means you can say a place that can hold a coming value, upcoming values. So just define a matrix of 56 cross 56 because we know 56 cross 56 values are coming up. In the next layer, this 56 will be applied with a filter size of 5. So 56 minus 5 upon a stride. A stride will be what? A stride is what? 1 plus 1. That's why we are getting what? 52. Okay. So this formula will be used to define how many inputs will be there in the next layer. Okay. F equal to 5 in this case is filter. It is random. It's your wish. F you can select 3, you can select 5, you can select, means generally we select in a odd number so that there can be a center defined, right? So you can select 3 also, you can select 5 also, you can select 7 also. So the data is quite huge. That's why if I select 3, then it will be like, it might get more complex, right? The processing power might increase. That's why I'm using selecting 5. In the first example, I have selected 3. So if you do the calculations using that thing, so it was 6. 6 minus 3 upon 1. So 6 minus 3 upon 1 is 3. 3 plus 1 is 4. So that's why from 6 we are converting into 4 cross 4. And from 4 cross 4 we have converted to 2 cross 2. Is it clear? Yeah. So this is your what? Convolutional layer. This is your definition of your convolutional layers. Now input layer is defined, convolutional layer is defined. We have selected filter as 5 cross 5. Okay. Activation is ReLU that we know. Thereafter max pull. Max pull means what? Means out of 5 cross 5 value, I'm just pulling out the maximum value. And pulling out the maximum value, and after pulling out the maximum value, what am I doing? I am passing that value to the next layer. Okay. Thereafter, what am I doing? From the next layer, we are again pulling max, and then again that passing value to the next layer, and then from that layer pulling the maximum value, passing to the next layer, then again pulling the maximum value. Okay. So after pulling the maximum value, what we'll get after 46, we will get 42 cross 42, right? We will get after this again we will get a 40 cross 42 cross 42. Okay. So what is the output of 42 cross 42? Can anyone tell me? 42 cross 42 will be what? Calculated, no? Okay, 1764, right? 1764. So if it is 1764 means what? If it is 1764 means what? In the next layer means convolutional layer, max pool layer, and after max pool layers, we have to use what? We have to use fully connected layer, right? So fully connected layer will have an input of 1764. Fully connected layer is going to have an input of 1764. So define it. Okay. And I want to do 50% dropout. So 50, it will be 1764. Okay. And thereafter, this layer is going to be connected to your output layer. So define this thing as the output layer. So in output, we are having two things. That's why two. I will share the code with you. Don't worry. And this is also present on my GitHub account. So you can get from there also, but I will share. Understanding is important, right? Code you can get a lot of sources are there, right? So it is just cat versus dog. That's why this many things are there. Okay. And at the last, softmax is applied. All of you know why softmax is used. That has been explained earlier. Okay. Thereafter, you have to optimize it. So you can optimize it using regression things. Okay. Earlier we have used a sparse categorical cross entropy. Here I am using categorical cross entropy. Just keep in mind because it will help you to understand one very important aspect. I will explain. Just keep in mind as of now. Thereafter, just compile the things using DNN. So model. Now my model is name is model. So thereafter I have to just fit the data into model. Which data I have to fit? I have to fit training data, right? So just call training data. Training data is not defined. Why? Oh my God, training data is in the, look here, the training data is defined within the loop and we have not used any return function. That's right. So we have to use a return function as well, right? Means the function should be of return type. So basically, we have to use return training data, right? So you can implement it. Now, data equal to create train data. Again, I will execute it. So data will contain all the values. Let it be executed. We will continue our code because after this, all of us know what to do actually. You can go, you please don't apply this kind of thing over in your code. You know how to define train and all those things. I had given you so simple way. In this thing, it is quite complex. then the whatever I told you, okay, whatever the way I told you for getting the features and labels was the simple way. If you use this particular thing, then it will be a complex. You have to write so many lines of code and you'll get confused also. So please don't use this thing. As of now, I am using it because it is already coded with me. That's why I'm using it, just to make the things faster. So feature extraction part, please do just like you did it. Don't try to do like this. Okay, is it done? Let it be done, then I will just execute it. Yes, yeah. Okay, it is done. So what I'm doing, last 500 value, I just ignored last 500 value for testing, and top 24,500 value I'm using for the training. Okay, you can use train test split also if you want. This is a slicing thing used over here, right? Thereafter, I have separated the X and Y because in the data both are present, X as well as label as well as feature. Okay, so I have separated X and Y, right? So you can separate it, and after separating, I have to feed the data in the model. So how to feed, there is little bit change over here. That thing is important. You have to just use model.fit, but not just usual model.fit. It is having a little change. I will explain the change. First of all, it is model.fit. You have to define input X. Why input X? Because while when you created it, you have defined a name input over here, right? In input layer. And at the output layer, you have defined targets. Okay. So that is the reason we have defined what input is X and target is Y. Then number of epoch is 10, means total 10 times training will be done. Then validation set will be defined over here only. Okay, so validation set will be test X and test Y, means it will give you after completing this particular thing, it will give you what? It will give you training or as well as testing, both accuracy. Okay, both accuracy you can get. Then show metric equal to true. This thing is not required run ID and all. Just it's you can just ignore it, and then you can execute it, right? So let's see. So you can see the training is started, right? So as the training is started, my accuracy is around 58, 52%, right? Here it is 50% something. Okay? And as it proceeds, I will get my better accuracy, right? So you can also do it. So what I was explaining, I was about to explain about sparse categorical entropy. Look, here I have used categorical cross entropy. In before program, in the earlier program, like the program that we discussed, we had used sparse categorical cross entropy. There is not much difference between these. You can use sparse or you can use categorical entropy. The only thing you have to define, suppose if you are using a sparse over here, a sparse categorical cross entropy, then you have to define the label like just one value, like it is going to be either 1 or 0. You can see for each label I have defined two value over here. It is 1 0 for cat and 0 1 for dog. Okay, if you remember the previous program, the program that we did yesterday, there we had defined just single label. Okay, for person it is 0, for car it is 1, for motorbike it was 2, right? But if the same thing that is for sparse categorical cross entropy, if you use categorical cross entropy, then you have to define like this. Okay, then you have to define something like this. I will write over here, just a minute. For person you have to define return 0 0 comma 0 comma 1. Okay, for car you have to define 0 comma 1 comma 0. For motorbike means this will take the value in, this will take the value in what, binary. Like yesterday someone is asking me like, is it takes the value in binary? So if you use sparse categorical entropy like yesterday, you are not required to define like this, but if you define just category, this is just two types of definition, that's it. It is just two types of definition. So if you use categorical entropy, you have to use like this. And what is this -3? Don't get confused with -3. It is just like you can use 1 or -3. -3 is from the last you are taking. If you are taking the value from last, to the -1 -2 -3. That's it. So you understood the difference between sparse categorical entropy and categorical entropy? Which code are you telling? Then only I can, because if you can just share me some examples so that I can explain, right? Okay, it is like you are saying in different platforms there seems to be very complex, the training and testing part are same, but they also perform many other steps in between. Okay, look here, what are the other steps you have to do? Like we did, they used to find something like look, for everything there used to be a two ways. One is easier way, means easily you can do the thing. Second is complex way, right? So whatever the thing that I taught you, I tried to make the things, more things covered in a simple easier way, because if you have to do it a complex way, then why to take the trainings, right? So the thing is, what steps generally people uses, like covariance people can use. Okay, correlation they can found. Okay, so these are the things they can, or the things that you had asked, what was that, just I explained at the top, that is a correlation thing, right? So it is like using these steps or using like k-fold correlation and so many data analysis kind of things, means if you get the data, it is not like that directly you can apply the data, right? We had discussed the data science part, that's why we discussed the data science part at the very beginning. Okay, so first apply the, you have to extract the meaningful data, you have to extract the meaningful information from the data source, data set, and thereafter we have to work upon that. Okay, if we apply the algorithms, and generally people apply 2 or 3 different algorithms. Okay, correlation calculated upon different algorithms. First apply this one, that one, and then like SVM, recently classifier, random forest, and all those algorithms. If you know how to use one algorithm, you can use any algorithm. Okay, so they apply like this. Okay, how to display the original feature? Look here, Parthiv, if you are using feature reduction, okay, feature reduction over what, over that we did, means dimensionality reduction you were talking about, right? Dimensionality reduction, right, Parthiv? PCA, the PCA that we discussed, right? Yeah, so in that case, if you reduce the feature, right, then why to the original feature might have been already stored in a single variable, right? It is not like that you are destroying the original feature.
Yeah. So it is like original feature is there in its variable. The new reduced feature you can store in a particular variable. So that is one of the things that also you can use. Many people don't use feature reduction. Many people uses feature reduction. In some cases, after reducing the feature also there is no change happen. Okay. In some cases it also happens that you reduce the feature but there is no such change happens. Okay. So in that case feature reduction is not working. It is, please do take care. If certain things you are learning in machine learning, it is not like that those rules you can apply in every problem statement. Every problems are different, every data are different, right? So in some cases feature reduction will affect your output very kind of you can say in a very good way. In some cases it will just not affect the things properly. It will there is no effect with feature reduction. The same way standardization, you can see last day when we were training the things, we are not using the normalization. We had not normalized the data. You can see you had seen the accuracy was 35-38%. Okay. But as you normalize, our accuracy increased to almost 90%, 100%, right? So that is the case. Means in some cases that worked, in some cases that will also not work. So it is not, it doesn't mean that the concept is not working. It means that it totally depends upon the data. In certain data, the standardization will work. In certain data, it will not work. Okay. So that thing you have to check. And the same thing Stans is talking about. People used to check those things. That's why the code gets complex. Okay. Okay, okay. You were not able to display the images. Okay, I will tell you how to display the images. Same process. Look here. Now it is third epoch, and after third epoch, accuracy touches 70%. Okay, and this is the final accuracy that you are getting, right? So two things you had not used in your case. You had not used CNN. Okay, and second thing, you had not used learning rate. That's why your accuracy was little bit poor. So shall I share this code with you so that you can also try, right? I will share only the CNN part because I don't want that you should use this particular complex feature extraction part, right? Because feature extraction part is something that is just a headache like this. It's a quite complex thing, right? If you don't, you should use the CNN part only. It will be good. Just use the CNN part based upon your feature extracted and just make that change, a sparse categorical cross entropy, because you might be using 0 for dog or so 0 for cat and 1 for dog, right? Or if you are, or if you are using something else, if you have to use just categorical cross entropy, then make the changes according to code. Where to share it? There are a lot many projects are there on my GitHub account. Okay, I had shared some projects. You can just go through the things, and codes are there. Just work on that codes and try to make the code simple each time you go over there. Please don't just use copy paste, right? Because the same code can be done in a very simple way. Straight. Okay, so please get the code and try to do it. Just try to solve out the errors and all. And if you face any difficulty, you can ask. And I will tell how to get the image as well. Don't worry. So you can see the training is going very slow because it's a very complex data. So it will take some time. There are certain models people used to train, like it takes weeks and weeks, like months and months. And people used to give like the cars, like supervised, you can say autonomous car. The training is still going on for autonomous car, right? Okay, you can continue. Just check out the things, whatever the problems you will face, you can just ask and sort out the problems. Okay. In code, LR has been defined, but I cannot make where it can be applied. Okay, you can apply over here. Here it is. In the optimizer. In the optimizer, generally we means in the in not up in the compilation. In compilation, you can use it. While you compile, there only you have to use it. Learning rate. There also in compile model.compile in simple ANN. There also you can use learning rate, right? You can see how things are changing. It is increasing and decreasing errors and all. It's a very huge calculation going on. That's why the simple library like scikit-learn and all those things can't handle this kind of huge calculations. Only TensorFlow is capable of doing it, right? That's why TensorFlow is used. That's why TensorFlow is so much in demand in the industry.
Okay, Shreyans, the thing is, you have to, you can do this thing, but again, you have to, uninstall Anaconda and you can install in certain other drive. This thing you can do, right? No, you can easily uninstall because your file will not get deleted, right? Whatever the code you did, no, the code will remain as it is. Your code is not going to delete anyway. Okay, like it is in documents section, it might be in documents or it might be in user and all those things. Only software will be reinstalled. Right. So it is not like that installing the software is like deleting the code. The libraries are too large in this thing. So there's no other way. Means, this is very heavy software. That's why it is created, because this kind of, for normal basics you can use Python also. The For the normal basics we did, okay, whatever we did before neural network kind of thing, whatever the basic things are there, you can use the conventional Python. But as you touch this kind of things, okay, the conventional Python totally fails. Means it will just kind of, your system will hang a lot. Okay, so in that case, Anaconda manages the things very properly. So that's why it is highly recommendable. With touching accuracy level of around 80% and then coming back, then again touching it.
What you want to just cut and paste, or yeah, it will work. Cutting and pasting, the only that thing about location you need to change. But again, just cutting and pasting is simply is like I want what I want actually. You should create your own, means you should create the things on your own. These things you can cut and paste. I will tell you, because this is what the conventional way means. This is something that will not change. Okay, anyone will code in the world will have to write this thing only. If anyone is using tflearn, they have to write this thing only. They can't directly define anything else if they are using tflearn, right? So this you have to do the cut and paste only, because here we can't do any change, right? The first layer, second layer, third layer, right? Yeah. Files environments. No, it will not work. No, it will not work because there are. It's a multiple location. There are so many things that are stored at multiple locations. So they can test if we can check if it is over, but I guess it will not work because there are multiple files are there, multiple dependencies are there. So they're internally correlated with each other. So I don't think it will work. All will again go to users. Why? You can again define the location. You can manually define the location as well. Is it not coming up defining the manual location? It's showing like manual definition of location. Yeah, it will come definitely. It will ask you the location when you install. It will definitely ask the location, which location you want to install. You can manually define the location. Okay, Parthiv, training data is a feature. Training data is what? Training data is a combination of feature and column both. Sorry, feature of combination of feature and label both. In training data, we are having both things, features as well as labels. Okay, what we did, yeah, so we have to separate the feature and label. That's why I have to separate it using this one, X and Y. But if you follow the steps that we did yesterday, okay, this process will not require, because there we are already separating, we are already picking the label separately and feature separately, right? In the yesterday program, what we did, the features and labels both were separated separately in X and Y. So this process is not required. You can directly use. Okay, the only thing that you have to take care was this thing, because over here I am using categorical cross entropy. That's why I explained. And yesterday I have used this sparse categorical cross entropy. So there are two ways of calculating cross entropy. So if it is categorical cross entropy, you have to define the label like this. Okay, if it is sparse, then the way that we defined yesterday, same thing. Here it is a function basically, and function is called within the training data. That first function is called within the second function. Okay, that's why this training data is containing both. First, np.array img. Img is what? Img is your feature, right? And second, np.array label. And label is what? This one. So this training data is containing both feature as well as label. That's why you need to separate it. Okay, now accuracy after 9 iterations, it is touching almost 85%, right? That is good. What is the last iteration, or you can say last epoch? Let's see. It's 85 around. Okay, so it is done now. You can see the things. Training has been done over 24,500 data, right? And final accuracy is what? 85%. Okay. And validation accuracy is what? Means the rest 500 data, that is total 25,000 data. Based upon rest 500 data, the validation accuracy is showing 79%. Okay, so it is almost close enough. Okay, 85 and 70, it is not too much far, so it can be acceptable. That is, you can imagine like this can be enhanced more if you use more iterations. Okay, because I had used just 10 iteration because this is quite complex data, right? So after 10 iteration, this is a case. If you can use more iterations, if you have a time, then you can do it. Then come to a part like Parthu or someone had faced, I don't know, like what was that? Image, like you are not able to plot the image, right, Parthiv? So we'll see first of all x test. Okay, test x, test underscore x. What is this? This is your data, right? This is your data. So what this data is having, the shape we will find out. So shape is what? 500 cross 60 cross 60 cross 60, right? So what we need, if I want to predict something, I need to take any one value. So I will take a value called 40 because total 500 values are there. So this is 40. Okay. Now if I have to make the predictions, how can we make the predictions? All of us know we can make the prediction in model dot predict, right? And here we have to pass some element over here, this thing. Okay. Dot reshape, because training has been made on 4 dimension. So 1 comma 60 comma 60 comma 1. So just see. So it is showing some output like this 0.46 0.53. So we know how to get it. We can use np dot arg max, right? Oh, arg max, right? So this is how you can get the predicted value, that is 1. Okay. So 1 will be for what? When we had defined for, let's see, one we have defined for what? One we have defined for it is defined for this one, dog, right? One has been defined means what that means? That means if one this position is having a higher probability, that means it is a dog. If this position is having a higher probability, that means it is a cat, right? So one is for dog. Let's see the image of dog or not. So how can you see the image? We need matplotlib. So import matplotlib dot pyplot as plt dot im so what x test 40. Okay, and then plt dot so. Right? X test is not defined because it is test x. I'm sorry for that. Test x. Okay. Now it is again showing error. Let's see why. Invalid dimension for image data. Okay, the data dimension it is showing is invalid, right? So what we'll do, right? So we got certain images over here, right? It might be it is looking almost like dog, right? So it is what we are getting basically. We are getting an image of a particular dog. We are getting a particular image based upon the resized data, right, Parthiv? If I need original data, then what, or you can say original image, then how can you get the original image? The original image, as I told you yesterday, you have to store this value separately. This img value needs to be stored separately. Got it? What we're doing here is the img, and likely I'm putting the img over here. Okay, so I want this thing from you, like you should do it over this data because I had explained this thing yesterday. Is it? I'd explained this thing, right?
Anyone can please tell me, like, you remember or not? Like here and here, I use different variables. Like here it is img, here again img, but I stored the value, the original value, in separate variable. Okay, if you stored the value in a separate variable, then what will happen? If you see the, if you didn't, then please see the previous code, the yesterday code. Okay, as you see the yesterday code, you will see like it will be different variables that I have used. Okay, and if you use different here img, here img, just if you change the variable over here. Okay, you can change certain different variable. If you use different variable over here, suppose in place of img, if I use k something, then img will not be affected out, right? So from img you can generate the original image, but here it will be not easy to generate the original image because we have changed the img only. So it is showing an image of some dog only. I don't know like it is really a dog or not, but it is looking like almost a dog, right? You can get the image through cv2 also. How can you get it through cv2? If you use cv2 dot imshow and the same image, so this is cv2 dot wait key, cv2 dot destroy all So you can see I'm getting some image over here. It is looking like a dog only, right? I'm getting again a small image because it is again sized down, right? Okay, it is sized down, that's why I'm getting such a small image. So it is looking like a dog and getting predicted as a dog. So this is it through which you can work upon the image data set. One small thing also I want to tell you, that is about uh, just a minute, handwritten digit recognizer. Okay. So what happened in handwritten digit recognizer? For handwritten digit recognizer, you had, just a minute, you did the codings, right? You did everything, but it is about from the image you have to pick the kind of a handwritten digit image, and then it can be predicted. As well as you can create a GUI from where the user can directly draw image. This thing also can be done, and then you can make the predictions. Okay, so let me tell you how is it possible, because I want that this project also you should do, but I will tell you only some part, rest part you have to do. Just a minute. Okay, so this code I will share with you. Let me explain the thing. What will happen? As I execute this code, it will give me an interface, right? This is what you will learn with the Python and all, right? It will give me an interface. You can see. Can you see the interface? Okay, this is the interface, right? Here you can draw an image, right? As you execute this code, okay, suppose an image has been drawn. So what you have to do, once this image is drawn, sorry,
I will again execute. Okay. Suppose a image is drawn like this. Okay, and as you click over save button, okay, as you click over save button, what will happen? The image will get saved. What will be the location? The location of image will be the same on which you are basically coded. This particular United Untitled 62. Untitled 62 is having certain location, right? In the same location, image will get saved. Okay, I will show you. It is saved. I will close it. I will go to that location. It might be some documents or just a minute. Users, people. So it is over here. And the image name is what? That you can see in the program. The image is saved. All this thing has been mentioned is of plot, like how this interface will look like. It will have a height 200, height 200, and width 200. So image name is what? Image.png. So let's open image.png. It will be, okay, this is image.png. Look here. So what you need to do actually complete, sorry, I guess some mistakes we are doing. Okay, it's image.jpg. I need image.png, right? Okay. Okay, this is image.png. Right? So what is, it is two showing over here. Okay, because I have drawn two over there. Okay. Again, I will open up. So this is Python part. So if you know Python, well and good. If you don't, then you can learn Python, then create more interface like that. But till then time, you can directly execute it. If you just draw certain kind of image, it can be some face you can draw. Okay, like emojis I was talking about. So you can directly detect the emoji. Both you can use. Either you can use your face. You can, like, camera can use for capturing the face, and once the face is captured, emoji can be generated. Okay, or you can use like this, like it is showing some smiling or something like that. As I save it, it will be saved somewhere. Which location? Same location. Open this image.png. It is saved. So basically the complete thing is, once it is saved, you have to pick that image, you have to extract the features, and then you have to make the predictions. Got it? You have to make the predictions just like we were doing as of now. Okay, that means you have to create a actual handwritten digit recognizer. Okay, train your model using the data that is already there on Kaggle. Once your model is get trained, use this particular thing to get an interface, and then draw the things and just check how well your how well the data is getting predicted. Okay, if it is predicting correct, it is not predicting right, any problems you are facing, then how to solve those problems, how will you solve the, what problem basically you will face a problem like the data that you use is of 28 cross 28, but here it is 200 cross 200. So this problem you might face because of huge difference in resolution. Okay, so you can change the resolutions. Okay, and after reading the data you can resize it. Okay, a lot many things are there that you can use upon, right? And after completing, you can again see if any difficulty you face, you can search for it. You can go through the things, you understand your data, what difficulty you are facing, and still if you can't solve, then you can just pin down a mail. We'll try to resolve your problem after going through your mail, right? So first you should try, because it's only if you try you will learn a lot. So I will share this code. Okay. Is this CNN is working for you? Parthiv, Aman, Shreyans, is it working? CNN part? Okay, great. Do it. Now we are no more beginners, right? Because there are three levels of learner. One is called beginner, one is called intermediate, second is go or advanced, right? So now you are no more beginner, right? So you are at an intermediate level. Now you can learn the things at like that only because basics you already know. Image after feature reduction. What happened image after feature reduction? Not feature reduction. Here, I don't think feature reduction term should be used. Here we are resizing. Means you can say what you are doing over here. It's a mm, it's something that is called compression. You are just compressing the image. This thing you can do. You understand? So feature reduction is something different. We are not doing that thing. We are compressing the things over here. Means image is of size suppose 100 cross 100. We are making it of 60 cross 60. So basically, two one and a half kind of a pixel will combine with each other. It's like that. Any development, any doubt? If suppose you are stuck somewhere, you can just ask, right? If image is not working or some might be some problems you might face, so you can ask, right? Since EGM model is getting trained, what accuracy is it showing? Parthi, what's yours?
Am I audible? Yeah. What is the latest status? Like, what at what point are you working? Like, I can't get it. It was so much time. Like, it's almost 45 minutes you are working. Can you tell me, like, I can help you if some problem that you are facing. You can directly share with me, right? So please do share, right? Okay, you got stuck, so you restarted. Okay, no worry. It's taking long time for extracting features. Okay, so are you extracting the features in terms of kind of a grayscale or colored? Please extract in the grayscale, because if you work on the color, then again it will take so much time for the training as well. Okay,
So grayscale is recommended.
Okay, anything you want to discuss about the projects that I, all of you have noted down the projects, right? All of you have noted down the projects. Anything you want to discuss about any sorts of project, like you are having a 15 project things I have shared with you, 15 project ideas. So do you need to discuss anything about this project's idea, like how it can be done? What are the uh, what will be the approach? Okay, will it be supervised, unsupervised regression, classification? What we have to do? Okay. Phase detection, right, Parthiv? How is phase detection done? Look here, for phase detection, you know how to train a phase, a model, right? Next thing, you should know how to capture a phase, right? So how to capture a phase, basically, once you capture a phase, then after easily you can do it, right? So I will tell you, look here, that's why I said, if I'm giving you something, just a minute, you have to capture, you should know how to capture the phase. So how can you capture the phase? Basically, you can capture the phase by using certain kinds of CV2, because CV2 is only thing for the phase kind of thing, right? For sorry, image kind of thing. If you have to work on the image, the only thing that you can trust is CV2. It's a
best open source library, OpenCV library. CV2 is your OpenCV kind of thing, right? So it's the best OpenCV thing, right? Best, you can say computer vision thing or image processing thing, right? So basically, uh, it would be like there is a function in CV, OpenCV. I'll just tell you the function name. Just give me a, because if you click over, if you read all the documents of OpenCV, you can get the get every each and everything. So basically, you can go two ways. There is a first way in which you can use a stable image. Okay, if you are using a stable image, then from that image all the face will be detected. For example, I will show you. Just a minute. That's why I said please have a look over the GitHub link that I shared. Okay, because this GitHub link will help you a lot, because so many projects I had shared over here, just to everyone can go through. So you can see over here, using CV2, you can CV2. You know what is CV2? You can see this particular browser, right? All of you, right? Browser. Yeah. So CV2, all of you know. Then image path. What is basically image path? There can be some image location from where you can just define the image path, right? Then the next line is hair cascade frontal default dot XML. This is one of the algorithm. You can say it's one of the file that will be used for face detection. It's algorithm that will be used for face detection. Now you think of from where you can get this particular file. Okay, you can get this particular file from my GitHub things only. I have, it is open source file. It is open source software. It's an open source algorithm. You can download from, just you have to search over Google from the official things also, or you can get it from my GitHub things also. Okay, so you can see there are lot many hair cascade files are there, right? Hair cascade eye, frontal face extended, okay, left eye, right eye, full body smile, okay, to detect a smile and all. The CN plate numbers, this can be for number plate and all those things. So this is algorithm that is already created for that. Okay. So to define the algorithm, okay, cas. After this thing, cvt.imread, all of you know imread do what imread do. It basically generates the feature, right? Thereafter, you have to just use this thing, cv2.cascade classifier. Okay, using a particular variable face. Okay, using a particular variable face, you have to use a function cascade classifier, and within cascade classifier defines the algorithm. That's it. After defining, you have to use these two functions are important, right? Only these two functions. Apart from this, everything is easy. What you have to define? Detect multi-scale. What is detect multi-scale? Within detect multi-scale, certain parameters are required. First, image. Okay, this is your image. Okay, same, right? That means you have to pass the image over here. Then it is minimum size. Minimum size means what? In that particular image, minimum this size, if face is smaller than 35 cross 35, that face will not get detected. Okay, face size should be at least 35 cross 35. That is the minimum size of a face from a particular image set, right? Then scale factor. Scale factor is what? Basically it works on a concept of slicing. Slicing means what? This is your complete image. In a complete image, there will be a particular area where face will be present. This will be the area where face will be present. So from this area, from the complete image, there will be limited area where face is present. So only this much things are important. This will be 35 plus 35. So how it will reach over here? It will reach over here by at the same time picking up different values from your data set. Like it will pick this much value. At the same time, it will pick at least 5 values. That's why 5 minimum neighbors are used. And the difference between the values will be what? 1.1. That is minimum scale factor. Okay, the difference between continuous value is going to be 1.1, like this. So at the same time, it will consider 5 random frame, and the difference between continuous frame will be 1.1. Okay, the features, the features difference will be 1.1, like this. Thereafter, through cascade scale image, it will just scale your image, okay, and the value will be stored in my face. And from my face will return you two things, sorry, four things. Okay, this my face. will return you what? This my face will return you four values. What are those four values? Those four values are this thing. And this is your image. Those four value are, first value will be x coordinate, that might be like 23. Second value will be y coordinate, that might be 54. Okay. It will return these two value x and y, that will be at the corner. Okay, it is basically, just a minute, it will return you, out of everything it will return you four values. So first value is what? This corner coordinate 23 comma 45. It can be anything, this corner coordinate. First value means this value, from where this value will get, this value will get from the detect multi scale after all the scaling and all those things. Okay, it's an inbuilt function that do the scaling and all. And third value will be what? Width. First we got width width, and last value is will be what? Height. So it's very simple. If you add width into x, okay, if you are going to add width into x, you will reach over here, right? If you add height into y, you will reach over here. And if you consider these both coordinate, you will reach over here. Okay, if you consider both coordinates all together, you will reach just diagonally opposite. So as you reach diagonal opposite, all the values will be just considered. Okay, all the values will be considered all together. Okay, and there will be a rectangle formed around the face. So this is how a face can be detected. First thing. Second thing, how many faces are detected, that you can find out by reading the length of my faces. Because if there is single face, there will be a x y w h. If there are two face, then then it will be x y w h for two times. If it is three face, then x y w h for three times. Okay. So as many faces are there, you can just get the length, pass the length, and you will get the how many faces are there. Next is this one. This is called your face capturing from the, this is second program, face capturing. What is this face capturing? The single function is video capture. Video capture 0 means what? You are capturing the video from webcam. Video capture 1 means what? You are using certain other resources. Right? So 0 you can capture the image, video capture. So it will just capture a single frame. Okay. Then it will store, you can store the value in a state and comma frame im dot read. What is im? Im is this value. Okay, im is this value. So im dot read. Im dot read means what? A state will have value true if face is captured. It will have value false if nothing is captured. If your camera is not working, camera is not operating, it will have a value false. Frame will have what? Frame will have the feature of the face capture. You can directly, and after you got the feature, you know what to do, because we did yesterday, we did today. You could just pass the feature in IMSO, and then you can get the image. So you got the image, you got the face, and after you got the face, or you got the captured the image, okay, whatever the image you captured using video capture, okay, from that captured video, right? What you have to do? You have to just predict, like, is their face present or not. So how can you predict is their face present or not? By using the above code. Okay. Just below there is one more code. This is for video, this one is for face, this one is for just image, still image. Okay, so just operate over it, because everything I can't tell you, you also put your effort, because till the time I had I make you to do the codes and all. So just do these codes, just try to figure out the errors and all, and just try to learn the things. And if you face any doubt, again I am telling you, just put the mail. So this is for video capturing, and you know, if anything I put in a for loop or infinite loop, the same thing here it is being there in used in loop. The same thing is being there used in loop. So this is for video capture. Okay, that means here it will be a single frame captured, single frame, and here it will be a continuous frame keep capturing. If continuous frame is keep capturing, that means you are capturing a video, right? And here is what it is like. In the captured video or in the captured face, it will just detect the, or in the captured image, basically I should say, in the captured image it will detect the face. So this is it. These are please don't use this NLP and all those things. These are not important. So this particular code is A to Z for face detection. It is very simple code. Okay, so please attempt all these things. I'm giving you the GitHub link. Okay, on this link, some PDFs are also there. So kind of for things
from where I can get the study material and all. So if you go to this link, PDFs and documents, so many things you'll get, right? Okay, I will data set we received to the predictions. Please explain the algorithm part, that is when in which type of data set we need to apply best algorithm. Right, Shreyans? Very nice question. What is a roadmap? The first thing that we should know, we just pick the data. Picked up. Thereafter, there is a pipeline we have to follow, data cleaning. Data cleaning, we clean the data. Means clean means what? Is there any kind of what null value present or some kind of a strings or something there? Processing, ex, extracting, encoding, and all those things. Okay, these things we do. Thereafter, data plotting. Thereafter, you have to plot the data using matplotlib. All of you know, like so many times we plotted using a scatter plot, using plot. Okay, so data plotting. Through data plotting, we get an idea of an algorithm. Which idea? Thereafter, on the data, you have to use like things. What are the things that you can use? It will be like correlation and covariance calculations. Thereafter, if required, then dimensionality reduction. If not required, then you can leave it. Thereafter, you have to check that you are having just features or labels. Okay, suppose you are having just features. Okay, there is no labels. Okay, so you have to go for, after this thing, you have to go for unsupervised approach. Okay, unsupervised approach is what? It's simply clustering kind of thing. And if it is having features and labels, go for supervised approach. And when you go for supervised approach, again you will have a two-way. One is regression, second is classification. So then go for, if we have to predict something continuous, go for regression. If you have to predict something category wise, go for classification. Okay. Then algorithms, which algorithm to use? Look, algorithm you can't decide by without applying it. In general, the idea is like, if your data is having a good separation, okay, the data is quite separated properly as you plotted, and after plotting you're getting, okay, it is being quite well separated and everything is divided. You can use certain algorithm like random forest or SVM, support vector method. Please do have research with SVM also. Okay. Thereafter, decision tree classifier. Okay. Otherwise, if it is not quite well separated, then you can use KNN, okay, XGBoost. Okay. So there are so many algorithms on which you can rely. Okay. So if it is based upon the data, based upon the things that you have to do, okay, so you can do over it. Thereafter, you are getting some not getting good accuracy, then what you can do, you can do the normalization, standardization. Okay, then you can deploy that thing, what is it called, uh, like what is that, k-fold. Okay, k-fold and whatever the things that we have discussed in today's class, so that thing you can apply, but that depends on the condition. That is not universal, means that it is not, I can't say that you will apply and all of a sudden improvement will be done. Okay, so that will depends upon the conditions. There are different steps that you have to apply and check. This is the only way, right? And with the regression, you can apply the things like linear regression, polynomial kind of things, right? Depends upon the situations, right? Okay, when to apply neural networks? Very good question. When we can apply Parthian neural networks? Neural networks are meant for heavy data sets. It is not meant for normal kind of things, normal like sales prediction or kind of classifications, normal things, or CAD cut for detection. Okay, so these things normal can be used with a simple, but neural network is basically meant for heavy calculations like images, videos, audios. Okay, mostly for, you can say, unstructured data. Okay, so mostly neural network used in case of images and all those things, like making a model for kind of automatically check the games. For example, you created a game, right?
and you want to make a kind of a AI based system that can automatically check the game, automatically work over the game, and can detect like without giving it into the real. Basically, whenever a game develops, what the people do? People basically just release the game some beta version, then people used to check over it. So you can develop a model that can check the games on its own. Right. So in that case, neural network will be used. In that case, normal algorithm will not work upon. And what is basically neural network? Neural network is also a same algorithm, right? But in a repeated way that is used. Okay, in neural network also same algorithm is used, right? Whatever we have learned before, but it is used in more complex way. It is used repeatedly. Okay, so it is not like that neural network is having something else. When you are using the same sort of algorithms, but in a repeated way, in a more complex way, that is a neural network. Right, Parthiv? Mostly images. How can we learn and implement unsupervised learning? How can we learn? I am not getting. Unsupervised learning you can learn from what? Learn means what? How you are asking like how can we decide that we have to apply? Is it? What are you asking, Science? How can you learn means what? You want to learn unsupervised learning because unsupervised learning has already been discussed. It is the clustering that we discussed, right? So you want to learn, or you are asking like how it can be decided that I have to apply unsupervised learning. Please make your question clear so that I can answer. Please, Science. Yeah. Okay, reinforcement. Okay, reinforce learning something you for the reinforcement learning for reinforcement learning there are certain points that you should know because our learning is mostly that's why I told it's a beginner things is finished as for you, right? There are three levels of learning in whole AI, right? One is called beginner, then we have intermediate, then we have advanced, right? So beginner thing is finished for you, right? Or means you are having a complete thing, complete concept like what is data and why data is used, how to use data, what are the, and if something is left also, then also you can just have a research and can do it, right? Because you have that much idea, okay, that much knowledge you are having means apply. Then at intermediate, there are certain different parts that we have to learn. Okay, so now your study will focus mostly over the terms like ANN we discussed. Okay, CNN we discussed. So just try to implement CNN more and more. Try to learn RNN, recurrent neural network. Try to learn LSTM. Okay, long short-term memory. So once we have the concept of these kind of things, okay, thereafter you can go for reinforcement learning because in reinforcement learning, these are the things that are basically used. Okay, so reinforcement learning you can say is the advanced level thing. So first complete the intermediate part like these things. Okay, just have a good sort of you can say project over this kind of thing, like make a project for example stock price detection, like how to detect a stock price and all those kinds of things. Okay, so in a stock price detection we use LSTM kind of thing. Okay, so once you did that particular part means intermediate part is over, then after go for this thing because this is the topmost part, reinforcement learning. Okay, so you have to complete before the prerequisite, then go for that thing, reinforcement, right? So RNN is first most important, complete RNN and LSTM. RNN and LSTM, if you understood, if you complete certain project using RNN and LSTM, thereafter go for the reinforcement. Like some more things are also there, like autoencoders. Okay, so like that, there are a lot many things are there. Okay, autoencoders also you should know. Okay, so lot many things are there that you should know in case of neural networks because I have given just you can say initial phase of neural network. Full body of neural network is still remaining, right? So you can go for that and then you can work upon reinforcement, right, Sriyans? Yeah, and just any suppose you're doing first complete the project that have been given to you, and thereafter if you continue learning these things and if you face any first you will try to solve the things on your own. If you still it is unsolved, then you can mail us, right? We will respond, right? Okay, shall we wind up? Okay, all those who needs to who are having more than 2 weeks of session, they need to complete the project. That is very means uh, submit the project report. That is very much compulsory for you. That without submitting the project report, again there will be a no project kind of a certification like that, right? And if you need like after completing the project any discussion session you want, you can just put the mail, okay, that any kind of a discussion you need, okay, about the projects or whatever you did or whatever the knowledge you're having. So you can put down a mail. If it is required for by maximum of you, we can have one more discussion session. That will be a short 1 hour or 2 hour session that we can conduct, right? Okay, everyone, just take care. I guess you got the things. I guess you enjoyed the session. I too enjoyed the session. Thank you, Sriyan. Thank you, everyone. Thank you, Parthiv, Kruti, uh, Aman, everyone. Just take care. Huh?